Karibu SolidWorks Tanzania. Yeah, this is another session on Siemens PLC programming. On the previous lesson 5, tulifanya some logic operations. Tuliona normally open and normally closed switches, tukaona AND gate, tukaona OR gate, tukaona NAND gate ambayo ilikuwa ni tusema NAND ni sawa sana kusema not A or not B. Tukaona pia NOR gate ambayo ilikuwa ni sawa na kusema not A and not B, lakini pia tukaona an exclusive OR gate as it seems here on the screen. Okay, so tunaendelea na other functionalities on PLC programming and today tunaenda kuangalia starting with holding and breaking contact. Okay, so we are creating a circuit ama a network ambayo inakuwa ina hold contact, lakini pia inaweza ika break, unakuwa na namna ya ku break contact. In other terms tunaweza tukaiita latching, you're doing latching. Kwa mfano ukienda kwenye viwanda ama hata kwenye mashine za kusaga, okay? Mashine ya kusaga unakuta kuna two buttons, kuna green button alafu kuna red button. Unakuta green button ni start push button alafu red button ni stop push button. So unakuta japokuwa unabonyeza start push button na au hold, una push then una release, but then the motor keeps on moving, like your machine keeps going on. Hapo umefanya latching. And then ukitaka ku stop the machine, you just push stop button and release, and then everything, the power supply to the motor stops. All right? Okay, so let's delete this network. Let me say delete this, and let's go to the show all tags. Let's say this is start push button, start PB, and let me name this as stop push button, stop PB, stop PB, stop push button. Na nilishasema normally stop push button inakuwaga na NC, inakuwaga ni NC switch. All right, when you push it then the input is high, then the output is low. Alafu start button inakuwaga ni NO switch, normal open switch. So when you push it then the output is high, but then since it's a push button manake una press then una release. Okay, so the output on the motor has to hold. So how are we holding the contact, right? So let's say the output here is motor. Okay, so let's go back to the main. So here, this is how we create a holding contact, holding and breaking contact. So let's call this holding and holding and breaking, sorry, breaking contact. Okay, so here we have a normal open start push button, a normally close for stop push button. Then here we have the output, which is the motor, and then we on parallel here we have how we are going to hold this. Okay, so this is how we create it. So here we have a start push button. Here we have a stop push button. Here we have a motor, and then here we tag again a motor. So this circuit that you are seeing here will be a holding contact circuit. Kwa press push button ya start push button, this motor will be on, and it will also trigger this to be on, to hold on. So even if I release the start push button, this will always be holding because it's reference to this one. So this will always be on after you release the start push button. Okay, But then if you want to stop the motor, then you have to push to start to click on stop push button. Okay, so let me compile this and then say online simulation, start simulation. So we say the working principle of this one. Okay, um say consider this as a trusted, say load. Here say start module, then say finish. Okay, after that say download to the device. So we'll download our network to the device, then load, finish, and then go online. Everything here is green, everything looks good. Down here error 0, warning 0, that's fine. Then say turn on monitoring. So you see now our motor is not running. So let's go to the sim table. Na unakutaga mara nyingi kwenye ile control panel ambao kuna start push button na stop push button, kuna kuwaga na LEDs, kuna kuwaga na start light na stop lights, right? Yeah. Okay, so let's say new here. This project, let's call it Siemens Siemens project 1, just a name. Why am I saving it? Uh, downloads and downloads. Okay, select folder, then create. Let's wait on it. Okay, let's wait on it. Okay, sim table here, right? Load the tags, right? So tukibonyeza start push button, then we will have our motor starting. So this is the start push button, toggle it, then you see our motor has started. If we release start push button, umeona hapa nime release, so start push button hapa iko force, nime release, but you see our motor is still running. Ndio kama kwenye system sasa za kwenye viwanda unakuta kwenye conveyor labda ama kwenye certain machine, hata kwenye mashine za kawaida tu labda za kusaga, lakini zenyewe zinakuwa zimefanyiwa electrical wiring ambayo inafanya holding contact na breaking contact, kwamba push button yenyewe unaipress then una release, but yenyewe inaendelea kufanya running. And if you want to stop the motor, then you have to press the stop push button. So if you press stop push button, then the motor has stopped and you release, so the motor has stopped moving. If you press start again and release it, you see, so that's a holding and breaking contact layout. That's how it looks like. Okay, so tunaweza so let me go offline. Tunaweza tukawa na 3 buttons, right? Ambao tunaweza kuwa kuna start button, pause button and stop button. So if you want to pause, you hold to pause, kwamba ile start push button una press release, una press button alafu unaachia ina start. Kama ni stop button, stop push button una press stop push button then una release, una press na release, ina stop the movement ama the machine. But pause push button yenyewe inakuwa sio push button, inakuwa ni push button ndio, lakini you have to hold on it. Yani ku pause the motion of the motor, you have to hold it. Ukirelease tu ina proceed where it ended. Alright, haisimamishi your haisimamishi your device ama machine. So behavior ni kwamba ukipress start the motor runs na inakuwa latched, maana inakuwa na hold contact, lakini ukipress pause contact ina open, motor stops moving. Hapo umehold pause. Ukirelease pause then the motor runs again. Okay, since the latching still exists, lakini ukipress stop everything goes off, manake latch is off. So let's create three buttons. So hapa what we will do first, let's delete this. Let me delete this. Let me delete that. Nije hapa kwenye PLC tags, let me add a tag here for a pause push button. Pause push button, na hii ni boolean lakini ni sio Q, sio output, ni input. So identifier here ni I, alafu address bit number, kwa sababu pale tuna I 0.0 na I 0.1, so itakuwa 2. So ni I 0.2 as an address. Okay, after that, let's go back to the main. Now here I'll have my normal close switch for stop button, then for pause button, then I have here a start button which I will latch it with the motor. Then here I have the motor. So hapa hii itakuwa ni stop push button, hii itakuwa ni pause push button, hii itakuwa ni start push button. Oh, sorry, start push button, hii itakuwa ni motor again for latching, and that's it. So hii hapa tutaita ni start pause stop. Okay, let me compile this and then download it to device. Load. Okay, alright, after loading it say go online. Kikataa najua tu mimi already itakuwa depleted, nita start over the simulation and then monitor. Alright, so nikija hapa niki call in all the tags again. Let me delete these ones. Let me try. Can I delete this? Yes. Okay. So here, let me press stop. Okay. See, like that. So normally in the beginning inakuwa like that. So this is how it is. Before I press the start push button. This is my circuit layout. So press start push button, press start push button, you see the motor is running. Hata release start push button, still the motor is running. If I want to pause, then I press pause push button. Mona hapo hold. You see hapa hold, lakini release, right? Then the motor has to let me see. Okay, it's not behaving the way I wanted it to behave. It's not behaving the way I wanted it to behave, because if you okay, so because hii hapa haipo kwenye real world, so inakuwa ni ukihold, ukihold ni kama una break contact, alright, lakini kiuhalisia itakuwa nikibonyeza pause push button. Okay, pause push button ilitakiwa ilitakiwa i pause tu ku run the motor, for a moment, and then ukirelease pause push button, ina proceed. So on a normal, on a real world setup inatakiwa kwamba only the stop push button ndio inayofanya stopping ya stopping ya let me try something here. Let me go offline. Let's say um let's say here, let's say this is pause. Let's say this is stop. If anything changes, let's be curious and try to change something here. Okay, if it doesn't work, I will search more on this one, and I'll come up with more answers, and then say compile. Let's download it. Load, and then say download. Finish. I don't know if we still have the memory. Okay, so if I press start push button and I release it, and then if I play pause, so actually pause push button and I release it. Okay, so the pause push button here actually stops. Fortunately, I cannot hold it and release. So nadhani inakuwa hivyo kwa sababu in this simulation I cannot hold it and release, you know. Kwa mfano hapa kwenye start push button una press, ina hold, una press na release, right? But to pause you have to hold it. Okay, you hold it, and when you release, everything proceeds. Okay. Okay. Um, so normally e pause is not stored. It only works while it's pressed. Okay, so the pause only works when it's pressed. So I think in the real world, this one will be working just fine. Okay, so let's get out of that. Let me delete this network. And go to another mechanism called interlocking in PLC. So interlocking huwa inafanyika for safe and reliable operations. For example, let's say you have two motors, and then they should not run at the same time. That means if motor 1 is running, then motor 2 should not run. Ama if motor 2 is running, then motor 1 should not run. Inakuwa ni kama for safety. Labda tuseme kwenye kiwanda chako una mota mbili ambazo labda zina move materials, okay? Labda of different properties, kwamba let's say kama unaweka material A, kama motor A is moving material A, then if you have to stop the material A going first, like you have to stop motor A, then you can start motor B to take in material B. You cannot run the two at par at the same time. Hii inafanya pia kazi sawa na kwenye zile mota ambazo zina forward, reverse motions, kwamba if unakuwa kuna button tatu tuseme, kuna forward, kuna backward ama reverse, alafu kuna stop button. So kama mota inaenda forward, umepress forward button, then ukipress reverse button haitaki ku respond kwa sababu now you will break everything, sindio? It's not safe. You have to stop first, and then you press the reverse button, then the motor goes reverse. Okay, that's how it goes. So let's write here the name of our networks. This is interlocking in PLC. Interlocking in PLC. Tumesema inatumika sana for safe and reliable operations. So let's say on network 1 here we have so let's say we are using motor. We have two motors. So you have start one, start two, start one for motor one, stop one for motor one, start two for motor two, stop two for motor two, and then you have motor one and motor two as output. So first tuanzie kwanza kwenye tags, and then hizi hapa naweza nikaanza highlight zote nikasema delete. So nikaanza kuandika tena upya start one, then start two, let's say stop one, then start two, push button 2 hiyo, start button for motor 2, stop button for motor 2, stop 2, and then you have motor 1. So motor 1, this is actually an output, so this is Q 0.0, right? And then we have motor 2, right? So after that, I come back to the main here, and now I create my two networks. So the first network is for running motor 1. So here I'll have a switch like this, normally close like that for stop button, a normal close like that. I'll tag motor 2 and then an output here, a parallel, an open like that and then closed. Alafu nitakuja kwa network 2. So hapa naweza andika motor 1 running, alafu hapa chini nitakuja motor 2 running, okay, like that. So hapa nitaandika nitachora circuit ya motor 2. So I have start 2, stop 2, I'll tag in motor 1 I mean, then output here I have a parallel to latch motor 2 and close like that. Okay, so here I have start 1, and then here I have motor 1 for latching, then here I have stop 1, then here I have motor 2 for interlocking, then here I have motor 1. Okay, so you see this motor 2 here, this is what makes the not being able to run both motors at the same time. If motor 1 is running, you cannot start motor 2. If motor 2 is running, you cannot start motor 1. Okay, and then down here I'll have start 2, and then I'll have motor 2, and then I'll have stop 2, and then I'll have motor 1, and I have motor 2, like that. Okay, so this will be my network. So whenever motor 1 is running, I cannot start motor 2, and whenever motor 2 is running, I cannot start motor 1. That's the interlocking that's happening here. Kwa mfano hapa ingekuwa labda ni in case we have a single motor lakini inaweza kumove forward and reverse. Manake hapa ningesema hapa ningesema ni forward motion coil, forward coil. Hapa ningetag reverse coil. Alafu hapa chini ningeandika reverse coil, hapa ningetag forward coil. Manake sasa nikiwa if the motor is moving forward, unless you stop it, you cannot press the reverse button and it responds. So if the motor is going forward, it will keep moving forward. If you want to take it in reverse, you have to press the stop button first, and then you press the reverse, then it goes reverse. Okay? All right. So let me compile this. Okay, and then let's say download it. Say load. Okay, then say go online. Say monitor. I don't know if it will. Okay, so the memory is depleted. So let me go offline, and let me first call the tags here, and let me delete this and see if that's the problem. Delete this and see if okay, that's not okay. So let me close this. No. So the memory is limited, right? Go offline. Okay, so here, so badala ya kuja huku online start simulation, pia unaweza ukaja tu hapa hivi ukasema start simulation, and then it will start the simulation like that. uh, say what? Okay, here. um okay, let me close this way. It doesn't give me. Let me come from here, say start simulation. Okay, don't know what's happening here. Online display errors. Let's see. Let me start search and see. Okay, nimeiona flash led, then load, consider as trusted. Okay, okay, load. Okay, here say start simulation, start module, finish. Right, now here tukisema okay, opacity download, so I have to download it to device, consider as trusted, then load, then finish, then monitor. Okay, now it's on monitoring mode. Right, so I'll press on this one. Let's wait on it to get the sim table. Okay, let's wait on it. Let's wait on it. Say new. Okay, which project is this? So project, let's say, okay, just give it the interlocking as the name. Interlocking, create. Wait on it. Okay, then a sim table here. Then load the tags. Right, here are the tags. Okay, so now let's see. So here on motor one, so if we have let me, can I minimize this? Okay, so we see we have start one for motor one. Nikistart motor one, so nikitoggle hapo start one, so start one, if we start one is true, so you see motor one here is on. even if I release the start push button, sababu tunajua push button ni una press alafu una release, lakini itakuwa imeendelea ku hold latch, so the motor 1 is running. So as motor 1 is running, if I want to start motor 2, let me press start motor 2 and you see if it responds. So start motor 2 is right here. Okay, start motor 2. If we start motor 2 here, start 2, you see nothing is happening. So motor 2 is not starting. Okay, so that's the interlocking. Kwa mfano hapa ingekuwa sasa labda badala ya motor 1 na motor 2 tungekuwa labda motor inaenda forward moving. The motor is moving, running forward. Na hapa najaribu kupress reverse, but it's not happening for safety, right? We don't want to destroy our system, lakini kwa hapa tunajaribu labda not to mix the operations, kwamba kama motor 1 ina run, motor 2 should not run unless motor 1 is stopped, then you can start motor 2. So hapa najaribu ku start motor 2 and you can see here start 2 is button is pressed, but unfortunately motor 2 cannot start since motor 1 is running. Okay, so we have to stop motor 1 first. So you come here, I release this one. So I have to stop motor 1, stop motor 1. So motor 1 is stopped like that. Now let's try to start motor 2. So come here, start 2. So start motor 2. Now start motor 2 is now running, even if you release the start button because of the latching. So motor 2 is running. So if I try to start motor 1 now, so motor 1 ni hapa, nikijaribu ku switch on motor 1, so start 1, so release stop 1, so start 1, you see it's not starting. So that's the interlocking in PLC. Okay, after the interlocking, let's see about multiple output with ladder logics. How so normally, so let me go offline here. We can have multiple output with a single input, or we can have multiple output for multiple. We can have a single input controlling multiple output. Manake unaweza kuta input A and B both are working, then maybe if input A is running, then run output A and B. Kwa mfano hapa tuna two motors na tuna start na stop, so tunaweza kutumia start button moja ku run both motors. So let me delete this. I'm just trying to reuse the tags. Ningeweza nikasema input A, input B, output A, output B, but let me just use the start buttons to start the motors. So first, let's see a single input controlling multiple output. Kwamba we have a single start button, lakini we are switching on multiple output. We are switching on motor 1 and motor 2. Can be more than two outputs. So how do we have that? So let's say single input to multiple output. So hapa a single input like this, and then you have multiple like this. So we can come here and say parallel to this and have another output like this. Okay, so let's say here we have start 1. Hapa let's say you have motor 1 and motor 2, right? So you see we have a single start button controlling two outputs. So let's say compile it and download it, say load, and then say go online and say monitor. I don't know if it will work. Okay, like that. So come here to the tags and let's start 1. So you see, so a single input can control multiple outputs. It's very possible. Okay, right. So the other option here, let me go offline, is we can have multiple input controlling multiple outputs. All right. Yeah. So, for example, for this case, maybe you can have start one for motor one, and then start one and start two for motor two, right? Okay. Let me add here. Let me add here start two like this. So that means if we start one, push start one, then start one itaanzisha motor one. But if you have start one and start two, multiple input, we will have motor one and motor two, multiple output on. Alright. So let's hear multiple input. So multiple input, multiple output. Let me compile this, download this to device, load. Okay, go online and say monitor. Okay, let's come here and say click this start one. So you see with start one we have motor one on. If we press start two here, so start one and start two give us motor one and motor two running. So multiple inputs and multiple outputs. Okay, I hope you have captured plenty in this presentation. Keep trying variety of circuits. Endelea kujaribu with different inputs, different outputs, jaribu different latching, interlocking, and stuff like that. And then you will understand how the behaviors of the switches and the inputs and outputs happens in Siemens PLC. So I hope you enjoyed the lesson. On the coming lesson, tutafanya some simple projects on using this ladder logics. Yeah, you are doing great. Keep moving forward, and we'll see you on the next lesson. Ciao.